Okay, I got a way better camera angle now. All right. So this question is 6.9 in your textbook. And remember, the first thing you do is draw a free body diagram. So all right, as you can see, we have a truss with 5 different joints. 2 of these joints, A and D, have pin supports. And if you remember, pin supports look a little something like this right here, you know? They got an X and a Y, but no moment though. That's very important, no moment. So I started off this question by taking the moment of pin A, and remember, since it does not have a moment, I can use that to find the upward force of pin D, which is also called your equilibrium formulas. So I used MA equals 0 equals D, 12, distance, R cross F for your your moment. And I used that to discover that reactant force at D equals 5 kilonewtons. And I used the Fy equals 0 to find Ay, which equals 4 kilonewtons, before I started working on the truss itself. Since I discovered the reactant forces of the truss at joint A and joint D, I'm going to start by working at the least unknowns. Looking at the truss, you can tell that the least unknowns are joint D or joint A. Joint A and joint D both only have 2 unknowns because their AX and DX equals 0. So I'm going to start at joint D. And remember, you don't have to do this, but I always assume that it is at tension for when I do it. C5. And if you notice, during the truss, they give these dimensions, which is, let me show you. It's 6 and 4. I'm gonna use that 6 and 4 as a triangle so I can find the X and Y forces of the horizontal line, diagonal line of DE. So next, after you draw the free body diagram of the joint, you are going to use your Fx and Fy equations to label and discover your members. Equals 0, and it would be DE plus DC equals 0. Oh, whoops, it's not DE, it's 4 over, hold on, let me use my calculator, because Pythagorean theorem. 4 squared plus 6 squared, 7.2. So it's 4 over 7.2, because that's the X component and that is the Y component, right? The 4 is the X, Y is the 6. After that, I used the Fy, which equals 0, and I did DE equals 6 over 7.2, again, Pythagorean theorem, minus 5, or actually plus 5 because it's going in upward direction. But if you noticed, if it's going in the upward direction, 5, that means I have to flip my DE as compression to balance out the 5 and the DC force that's in tension. So it's actually gonna look like this. Five. And now I put a minus here and I put a minus here because they're going in opposite directions now. So DE 6 over 7.2 equals 5. DE equals 5 over 7.2 over 6. Five, 7.2. I'm putting in my calculator, by the way, guys. You probably can't see it. 6. So So DE actually equals 6. Now that I know that it equals 6, I can plug it in my fx equation, which had 2 unknowns originally, and solve for that. DC equals 6, 4 over 7.2. And I got DC equals 3.33.